Hello, Dr. Zhang. I'm Wang Weijie from Group 37, and on behalf of our group mates, Cu Zhiyuan, Yang Bingshun, and Yu Shenli, to present our project. Our project is named Decoding the Debut. It's a sentiment analysis of ChatGPT's first month on Twitter or X, using 3 models to finish this NLP task and compare them. In this presentation with these slides, we would like to introduce the social background and the technical basis at first, and then illustrate the detail during our model training. It's valuable for us to understand the algorithm, especially when we use different parameters or architectures in some algorithm. These details could be a supplement for our report. Last but not least, we will discuss the application and the limitation. Let's go back 3 years ago. OpenAI released ChatGPT on November 30, 2022. It was definitely an aha moment for the AI world. The AI industry is experiencing a marvelous boost in these years. In terms of science communication, public opinions have ability to affect the fate of the technology and set the agenda of the policy and the research. In terms of marketing, it is also valuable to know the public or user's opinion to guide the development of a product. Based on our previous domain knowledge, we decided to conduct a sentiment analysis of the ChatGPT's first month on Twitter. We defined it as a supervised classification task. The input is raw tweet. The output is one of 3 labels: bad, neutral, or good. The goal is to train module that generalize well to unseen tweets. Therefore, we use Cargo database, ChatGPT sentiment analysis. It has nearly 220,000 samples with raw tweets and the sentiment label, which is typical supervised learning database. As social media content has a emoji, URL, and hashtag, we use unified regular expression-based cleaner. We can see a before-after sample on this slide. In the following training, we use split function to set the size for test, which is 0.2. We also noticed that the data is imbalanced. The percentage of bad label is nearly 50%. It reminds us that macro F1 and per class metrics should be used in evaluation. Moving to algorithms, the paradigms of NLP sentiment analysis has undergone a significant transition from traditional machine learning to deep neural network and now to pre-trained transformers. We select a representative algorithm for each stage for a fair comparison. We used the term frequency and inverse document frequency plus logistic regression as a baseline. And then in terms of recurrent neural network, we use the long short-term memory. Finally is BERT, which is a pre-trained transformer model, and we will fine-tune it. Now let's look at training details, starting with our baseline, logistic regression. We used TF, ITF for pre-processing, while fast and interpretable, it relied on the keyword frequency and ignored the word order. In our first iteration, we used the default parameters. In the second iteration, we implemented grid search for hyperparameter tuning. We optimized the n-gram range, maximum feature, and the class weights. As the chart shows, optimization improved performance across all 3 dimensions. However, the score for the neutral class remains low, since the neutral sentiment relied heavily on context. It confirms that our baseline struggle with the contextual understanding compared to the bad class. For the second stage, we choose LSTM to represent RNNs. Initially, we trained in a simple unidirectional architecture. However, since a standard LSTM only see past context, we upgraded to a bi-directional LSTM in our second test and increased the depth from 1 layer to 2 layers. The result were telling while position for bad and good fluctuated, the critical F1 score either stabilized or increased. Most importantly, performance on the neutral level improved significantly. It allowed us to infer that increasing depth and specifically enabling bi-directional processing greatly enhanced the model ability to capture context. Finally, we had the highest expectation for fine-tuning these two BERT. Even after just one training epoch, it achieved impressive results. We then invested the time and computational resources to train it for 2 epochs, yielding even more significant improvement. However, the process highlighted a key limitation: computational cost. The time consumption and hardware instability we faced gave us a profound appreciation for the resource intensity required to train the large transformer-based model. Vertically, within each algorithm, we see how parameters, architecture, and training epoch impact the result. And comparing these 3 models, because the dataset is imbalanced, we use F1 score to make a final comparison in this slide. The chart illustrated the newest architecture we used in these programs get the best performance, especially in the field highly depending on the context. It vividly demonstrated the necessity of the AI paradigm shift. To bridge theory and practice, we built a web demo. Users can input text in the left box. For example, ChatGPT is very powerful and good, and the module predicts the sentiment score on the right. As expected, this prediction is high positive score. Regarding application, sentiment analysis is already a mature marketing tool. Broadly speaking, it's also critical for policymaking, political forecasting, and macroeconomic analysis. However, future deployment faces clear limitation. As shown in our stress test, if I input a sarcastic sentence, the model often fails to detect the real meaning. When we input "Oh great, ChatGPT is done again," it told us it is positive. Meanwhile, the source of ground truth is a major pain point. Although we treat the dataset labeled as truth, we found instances clearly possible sentences were labeled neutral. When we input ChatGPT helps me code so much faster, which is likely to be positive but classified into neutral. We went back to the database to check how the data is labeled. We found that when the content is likely to describe a phenomenon without an emotional adjective, they will classify it into neutral. So we'd like to say that the data provider should be aligned with the real data user. Okay, in the end, to conclude, by navigating these 3 paradigms, we have understood their specific pros and cons and the inevitability of the shift toward transformer. At the micro level, we mastered the impact of the parameters and architecture. At an application level, we successfully deployed a basic demo. For the 4 of us, it was our first deep dive into AI algorithm, and it gave us a tangible sense of their power and potential. The final slide contains our references. Thank you, Dr. Zhang, for your guidance over the past month and a half. This concludes our presentation.